Pythagoras is back at it. But I have to admit, things have changed. Now the pool is only half full of water, and it's actually leaking at a rate of 3 gallons per minute. I want to know how much liquid catnip measured in grams is in my pool at time t during the time from the beginning of the experiment to when it fills up. Once it fills up, I don't want to discuss what's going on there. So if my question is clear, then notice how this doesn't change. So now let me put in the details. Not much to do on the left-hand side. It is what I have. Okay, it's time to slow down. On the right-hand side, check out that 3 gallons per minute fluid flow coming in from the left-hand side. That is a rate of change of fluid, not a rate of change of the amount of liquid catnip. So I got my 3 gallons per minute. I now need to likewise multiply by the concentration, which is 1/10 of a gram per gallon. Just like in my last example, things are looking nice, look at cancellation. But I need to subtract off the rate at which catnip is going out, which is not 3 gallons per minute. That's the rate of flow of fluid going out. I need to multiply by the concentration of the cat pollutant in the tank at time t. But I gotta confess, everybody, it's not quite as straightforward as last time. Let's you and I think of the concentration of salt. Excuse me, I keep saying salt. Let me think of the concentration of liquid catnip as nothing more than the ratio, the amount of catnip measured in grams, that's by the way that you know, to the amount of water in the tank at time t. Well, initially it's half full, so 50 gallons. But notice how there's 5 gallons coming in, 2 gallons going out. I misspoke. Notice how there's 5 gallons going in, 3 gallons going out. That means as time changes, that tank is increasing the amount of fluid by 2 gallons per minute. And so I think what I have is 50 gallons plus 2 times t. It makes a lot of sense. I refer to it as being measured in gallons per minute. But that's measured in minutes. Minutes canceled, that's measured in gallons. This is measured in gallons. Cancellation, we're in business. Now, I don't think I pointed this out last time, but notice how I don't have a second term for the rate at which is coming in. That's for this reason. If I want to, I can say, oh, I've got an additional 2 gallons per minute coming into this body of water as time goes by, but the concentration of liquid catnip is 0 because it's initially clean. I shouldn't say initially. The rate of flow of fluid is clean fluid. And so I would literally multiply by concentration of 0 grams per gallon. That's being silly. The whole second term completely drops out. That's why I don't include it. Well, let's see what happens next. Cleaning up, suppressing my units. Does that mean with this? And if I'm not writing too sloppy, does that mean with this? Now look at that. I think I've just rewritten the differential equation in such a way that it's in the standard form of a first order linear differential equation. Here's my p of x, or shall I say here p of t. Here's my q of x, or here q of t. I guess either way doesn't make a difference. It's a constant function. And you know how to solve a differential equation with the technique I've shown you.